Take a moment. Step away from this screen and find a mirror. Look closely at the person staring back at you. Study the lines on your face, the unique color of your eyes, the subtle scars that tell the stories of your life. Now, reach deep into your mind and hold on to your most precious memory. Is it the warmth of a parent's hug from decades ago? The exhilarating joy of your first love? The profound sense of accomplishment from a lifetime of hard work? Feel the emotions tied to that memory. It feels real, doesn't it? That face in the mirror, those memories, they are the very fabric of your identity. They are the undeniable proof that you are you. But what if I were to tell you that this entire tapestry of experience, this person you fundamentally believe yourself to be, is a lie? What if your consciousness, in this very moment, is nothing more than a spectacular, random, and fleeting illusion? A beautiful hallucination in an ocean of eternal, mindless chaos. This is not a question from a late-night philosophical debate. This is not a plot from a science fiction movie. This is the single most terrifying, most plausible, and most fiercely debated thought experiment in modern cosmology. A nightmare born from our own best and most rigorous understanding of the universe. It is the paradox of the Boltzmann brain. And tonight, we will journey into this intellectual and existential abyss together. We will walk the path of logic that leads to a conclusion so horrifying, it threatens the very foundation of science and self. We will confront the chillingly plausible possibility that you, the observer, are not real. To truly comprehend this cosmic horror, to feel its chilling weight, we cannot start with the brain itself. We must first travel to the furthest conceivable future, to the desolate, silent end of time itself. Our journey begins with a concept that is both simple and final: the heat death of the universe. Everything we see, everything we are, is governed by a fundamental, unbreakable law of physics, the second law of thermodynamics. At its heart, this law describes the relentless one-way march of time through the language of energy and disorder. It states that in any closed system, from a cup of coffee to the entire universe, the total amount of entropy, a measure of disorder or randomness, will always increase. Imagine a brand new deck of cards, perfectly ordered by suit and number. This is a low entropy state, a state of perfect order. Now, shuffle that deck once, the order begins to break down. Shuffle it 1,000 times, 1,000,000 times. The cards will become completely randomized. You will never, ever shuffle that deck and have it return to its original, perfect order. The system has moved irreversibly towards a state of maximum entropy, maximum disorder. Our universe is no different. At the moment of the Big Bang, the universe was in an incredibly low entropy state. All the energy and matter that would ever exist was concentrated in a point of near perfect order. But ever since that first fraction of a second, the cosmic deck has been shuffling. Energy is spreading out, matter is becoming disorganized, and entropy has been increasing. This process will continue for a span of time that makes our human timescale utterly meaningless. We currently live in the stelliferous era, the age of stars. It's a brief, glorious moment of cosmic springtime where galaxies are ablaze with the light of trillions of suns. But this era will end. In a few trillion years, the last star will exhaust its fuel, its light will flicker and die, and an eternal twilight will descend upon the cosmos. This will begin the degenerate era. The universe will become a vast, dark graveyard populated only by the cold, dead corpses of stars, black dwarfs, neutron stars, and the silent gravitational titans we call black holes. For a period of time so long, it makes the current age of the universe seem like an insignificant flash, perhaps 10 to the power of 39 years. This will be the state of reality. A dark, cold expanse where the only activity is the slow, gravitational dance of dead celestial bodies. But even this is not the end. The black holes, for all their power, are not eternal. Stephen Hawking discovered that through a subtle quantum process, black holes themselves evaporate. They slowly leak their mass back into the cosmos in the form of a faint, cold drizzle of particles. The process is impossibly slow. A supermassive black hole with the mass of billions of suns might take 10 to the power of 100 years to disappear completely. This number, a 1 followed by 100 zeros, is a googol. It is a number so vast that there are not enough particles in the observable universe to write it down. When the last, gargantuan black hole has finally fizzled out of existence, the universe will at last enter its final state. The black hole era will give way to the dark era. It will be a vast, cold, dark, and almost perfectly featureless soup of stray photons, neutrinos, and other elementary particles, all spread out so thinly across the ever-expanding void that they will almost never interact. This is the state of maximum entropy. This is heat death. It is a universe where nothing meaningful, nothing complex, nothing interesting can ever happen again. There is no structure, no life, no thought. There is only an endless, unchanging, and utterly boring equilibrium. For a long time, this was considered the final, sad, but understandable chapter of our cosmic story, a quiet end. But it is here, in this seemingly dead and empty void of the far future, that the true nightmare begins. Because in the strange and counterintuitive world of quantum mechanics, nothing is never truly nothing. And when you combine the quantum world with an effectively infinite amount of time, the universe has one last horrifying trick up its sleeve. It begins to dream. The seemingly placid void of a heat-death universe is, on its most fundamental level, a seething cauldron of hidden energy. This is the bizarre reality of quantum mechanics. The vacuum of empty space is not truly empty. It is a roiling, chaotic foam of virtual particles that constantly pop in and out of existence for infinitesimally brief moments, borrowing energy from the void before vanishing again. This is not a speculative theory. It is a cornerstone of quantum field theory, a proven aspect of our reality with measurable consequences. In our current high-energy universe, these fluctuations are minuscule and fleeting, their effects confined to the subatomic realm. But in the cold, thin, featureless soup of the heat-death universe, they have all the time in the world. And with a timescale that stretches towards infinity, even the most statistically improbable events are no longer just possible. They are, by the sheer force of statistics, inevitable. This is the profound and often terrifying logic of infinity. You may have heard of the infinite monkey theorem. If you place an infinite number of monkeys in a room with an infinite number of typewriters, one of them will, by pure chance, eventually type the complete works of William Shakespeare. The probability of any single monkey typing even the phrase "to be" or "not to be" is astronomically small, something like 1 inch 26 to the power of 18, but it is not zero. Given an infinite amount of time, that tiny, non-zero probability will eventually be realized. It must happen. Now, let's replace the monkeys and typewriters with the quantum fluctuations of the eternal void. Over trillions upon trillions of eons, a random quantum fluctuation might spontaneously assemble a few stray particles into a single hydrogen atom, a simple, common occurrence. Wait an even longer time, an incomprehensibly longer time, and a more complex fluctuation might create a small rock or a crystal. The probability is far, far lower, but it is still not zero. Wait for a time scale that makes the evaporation of supermassive black holes look like a hurried flash, and a fluctuation could, in theory, assemble something far more complex. By sheer, random chance, it could assemble a perfect, functioning starship adrift in the void. It could assemble an exact, atom-for-atom replica of the planet Earth, complete with its oceans and continents, for a fleeting moment. Or it could assemble the single most complex, most ordered, and most mysterious object we know of in the entire cosmos, a conscious, thinking human brain. This is the genesis of the Boltzmann brain, a concept so bizarre it sounds like fiction, yet so logically sound it keeps cosmologists awake at night. Named after the 19th century physicist Ludwig Boltzmann, who pioneered our understanding of entropy, a Boltzmann brain is a fully formed, self-aware consciousness that arises spontaneously and randomly from a state of perfect thermodynamic equilibrium. This is not a brain that is born, that grows, that learns. It is a brain that simply is. It flickers into existence, a perfect, miraculous assembly of trillions upon trillions of atoms, conjured from the random quantum jitters of the void. And here is the crucial, existentially terrifying detail. For this brain to be conscious in a way that we would recognize, it must have a framework for its thoughts. It must have memories. It needs a past, a history, a narrative. So, this spontaneously formed brain would pop into existence, complete with a rich, detailed, consistent, and utterly false set of memories. It might have memories of a childhood on a farm in the countryside, of the smell of rain on hot asphalt, memories of falling in love under a canopy of stars, of the heartbreak of loss, of the joy of raising children. It might have the memory of a long and successful career, of struggles overcome, of wisdom gained. It might even have the very specific memory of having felt a flicker of curiosity and clicking on a video titled "Proof You Aren't Real." The terrifying paradox of the Boltzmann brain. It would experience a single, coherent moment of thought, a flicker of self-awareness in the eternal darkness, before the same random quantum forces that miraculously assembled it would just as quickly tear it apart, and it would dissolve back into the featureless void from whence it came. A single, lonely, and utterly illusory life, lasting for but a second. This concept is profoundly unsettling. It challenges our deepest assumptions about cause and effect, about the linear progression of time, about the very nature of our experience. We believe our consciousness is the glorious culmination of a long, unbroken chain of events. Starting with the Big Bang, the formation of our galaxy, the delicate process of abiogenesis on Earth, the epic saga of evolution, and our own unique, personal history. The Boltzmann brain hypothesis brutally suggests that this entire causal chain could be a fiction. Your consciousness, with all its richness, depth, and emotional nuance, could be nothing more than a random artifact, a statistical anomaly in a dead universe. At first glance, this seems like a bizarre, philosophical curiosity, a fun but ultimately dismissible what if. But the true soul-crushing horror arises when we leave the realm of abstract possibility and apply the cold, hard, unforgiving logic of statistics. The horror comes when we realize that, according to our current understanding of physics, the universe should be overwhelmingly dominated by these lonely, dreaming brains. And that leads to the most personally terrifying calculation in all of science. This is the exact point where the argument shifts from a curious, abstract thought experiment to a potential, visceral nightmare about our own reality. It is a simple, cold, and brutal question of probability. We are conscious observers. We must therefore ask ourselves, in a universe that exists for a near infinite amount of time, which of these two scenarios is more likely to be the source of our consciousness? Scenario A, the conventional universe. A truly massive universe-scale quantum fluctuation occurs, creating an incredibly low entropy state, the Big Bang. From this initial order, an entire, vast universe unfolds over 13.8 billion years. Trillions of galaxies form. Within one of these galaxies, a star system is born. On at least one planet, through an incredibly complex and delicate process of abiogenesis and evolution, life arises. This life grows in complexity over billions of years, eventually producing a species with billions of conscious, ordered, and embodied observers, humans who are capable of observing the universe and deducing its history. Scenario B, the Boltzmann brain. In the eternal high-entropy chaos of the heat-death universe, a much smaller, more localized quantum fluctuation occurs. This fluctuation randomly assembles a single conscious brain. complete with a perfectly consistent and detailed set of false memories that makes it think it lives in the universe described in Scenario A. When physicists and cosmologists run the numbers when they calculate the entropic cost of each scenario, the answer is not just clear, it is horrifyingly, catastrophically one-sided. The probability of Scenario B, the single hallucinating brain, is exponentially, unimaginably, gut-wrenchingly higher than the probability of Scenario A. The reason for this is entropy, the very same concept we started with. To create an entire universe like ours requires a colossal, universe-scale decrease in entropy. It's a fluctuation of such epic proportions that it is the statistical equivalent of not just one monkey typing Shakespeare, but trillions of monkeys in every corner of the globe, simultaneously and by pure chance, typing the complete, unabridged contents of the entire Library of Congress. Without a single error, the odds are beyond astronomical. To create a single, small, human-sized brain, however, requires a much, much smaller and more localized decrease in entropy. It is still ridiculously, absurdly improbable, but it is less ridiculously improbable than creating a whole universe from scratch. It's a simple analogy. What is more likely to happen by chance on a windy day at the beach? An entire, perfectly formed sandcastle, complete with towers, moats, and intricate details, spontaneously assembling itself from the sand, or a single, complex, beautiful grain of sand spontaneously appearing on your desk 1,000 miles away. The single grain, every single time. The universe always prefers the path of least resistance, the path of the smallest required decrease in entropy. Creating a single brain is entropically cheaper than creating a whole universe to evolve that brain within. This devastating logic leads us to the Boltzmann Brain paradox, also known as the youngness paradox. If our current cosmological models that predict an eternal, expanding universe are correct, then the overwhelming majority of conscious observers that will ever exist in the universe should be Boltzmann brains. The number of these spontaneously formed, hallucinating brains, flickering in and out of existence over the eons, would be so incomprehensibly vast that it would dwarf the number of real, evolved observers like us into utter insignificance. So, if you are a conscious observer and you are a rational person who plays the statistical odds, you have no choice but to conclude that you are almost certainly a Boltzmann brain. The idea that you are a real person who evolved on a real planet in a real 13.8 billion-year-old universe is a statistically ludicrous, romantic, and arrogant assumption. Your most cherished and fundamental belief, your belief in your own reality is, from this cold, logical perspective, a theory with an infinitesimally small probability of being correct. This is the nightmare. This is the paradox. It's a radical, terrifying form of skepticism that uses the very laws of physics against us. The intellectual tools we have painstakingly developed to understand the cosmos are now telling us that our perception of that cosmos is, in all probability, a complete and total fabrication. Every person you have ever loved, every sunset you have ever marveled at, every piece of knowledge you have ever learned, every note of music that has ever moved you to tears, all of it is a phantom, a random neural firing in a disembodied brain that has no past and will have no future. You are the sole inhabitant of an elaborate, simulated reality that exists only inside your own skull. A skull that itself is just a temporary, accidental collection of atoms pulled from the eternal chaos. This isn't just a philosophical puzzle anymore. It has become one of the most serious and profound problems in modern cosmology. Many leading physicists see the Boltzmann brain problem as a reductio ad absurdum. If a cosmological theory logically leads to the conclusion that the universe should be filled with Boltzmann brains, then that theory itself must be fundamentally wrong. A scientific theory that predicts our own observations are false is a theory that commits suicide. It undermines the very basis upon which it was built. It's like a scientific paper that scientifically proves all scientific papers are meaningless scribbles. The theory eats itself, and so the race is on. In the quiet offices of universities and research institutes around the world, cosmologists are now desperately searching for a flaw in this horrifying logic, a new model of the universe that can save us from this devastating, solipsistic conclusion. They are looking for an escape route from the nightmare. How can we possibly escape the seemingly logical conclusion that we are just fleeting cosmic hallucinations? The search for a robust solution to the Boltzmann Brain paradox is not a fringe activity. It is one of the driving forces at the very cutting edge of theoretical cosmology. It forces us to reconsider our most fundamental assumptions about the origin, the nature, and the ultimate fate of our universe. The stakes could not be higher. It is a battle for the very foundation of reality itself. One of the first and most direct places to look for an escape is in the troublesome concept of infinity. The entire paradox hinges on a universe that has an infinite amount of time to produce these random, complex fluctuations. What if the universe simply doesn't last forever? Some cosmological models propose a more dramatic and finite end for our cosmos. For instance, the Big Rip scenario suggests that the accelerating expansion of space, driven by dark energy, could become so powerful that it eventually tears everything apart. In this violent end, the fabric of space-time itself is ripped asunder, first pulling apart galaxy clusters, then galaxies, then stars and planets, and finally, shredding individual atoms and the particles within them. Another possibility is the Big Crunch, where gravity might one day overcome the expansion, causing the universe to reverse course and collapse back into an infinitely hot and dense singularity, perhaps to be reborn in a new Big Bang. If the universe has a finite lifespan, whether it ends in a rip or a crunch, then it simply might not exist long enough for the astronomically improbable formation of Boltzmann brains to occur in any significant number. In a finite universe, the long, methodical process of evolution might be the only viable path to consciousness, making evolved observers like us the overwhelming majority. However, this escape route is not a certainty. Our current best observations of cosmic acceleration seem to favor a universe that expands forever, keeping the heat-death scenario, and thus the Boltzmann brain problem, very much on the table. This leads us to another, more popular and mathematically complex escape route, which comes from the theory of eternal inflation. This is the idea we touched upon earlier. Our universe is just one bubble nucleating and expanding within a much larger, eternally inflating multiverse or metaverse. While this model was one of the main culprits in creating the Boltzmann brain problem in the first place, because an eternally inflating multiverse provides infinite time and space for Boltzmann brains to form, it might also contain the solution. The key lies in solving something called the measure problem. In an infinite space filled with an infinite number of events, how do you meaningfully compare the number of real observers to the number of Boltzmann observers? It's like asking, what is infinity divided by infinity? The answer is mathematically undefined. You can get any answer you want. Cosmologists have been working for decades to develop a measure, a consistent and logical mathematical framework to regulate these infinities and allow for sensible probabilistic predictions. Some of these proposed measures, such as the proper time measure, seem to suggest that bubble universes which rapidly produce a vast number of evolved, normal observers like ours are heavily favored in the cosmic accounting. In this view, the process of cosmic and biological evolution is so phenomenally efficient at creating consciousness that it simply outpaces the slow, random formation of Boltzmann brains. It's a highly technical and mathematical hope that nature, on a multiversal scale, prefers to build consciousness the hard way through structure, evolution, and time, rather than the easy, random, and chaotic way. A third and even more speculative idea moves from physics into the realm of philosophy. It argues that the laws of physics themselves might implicitly prevent Boltzmann brains from being considered true, stable observers. Some physicists, most notably Sean Carroll, argue that a brain which simply fluctuates into existence is not a reliable or meaningful observer. To be a true scientific observer, You need to be part of a consistent reality where you can make predictions and test them against your environment. A Boltzmann brain, with its entirely fabricated memories and its fleeting momentary existence, cannot do this. It has a memory of a past, but that past never happened. It cannot perform an experiment or test its theories about the world because it will cease to exist in the very next moment. In this more philosophical view, the only real observers are those, like us, who are part of a consistent thermodynamic arrow of time, able to interact with our environment, learn from it, and build a coherent, predictive picture of reality. It's an attempt to save reality by defining consciousness and observer in such a way that it excludes these random cosmic accidents by default. While this is an appealing and intellectually elegant idea, it's more of a philosophical position than a physical solution. It saves us from the paradox by redefining the terms of the problem, a move that not all scientists are comfortable with. These escape routes are not guaranteed. They are active, vibrant areas of research, filled with some of the most complex mathematics and deepest philosophical debates in all of human history. The very fact that some of the greatest minds in physics are spending their careers trying to solve this bizarre problem shows just how seriously they take its implications. They are not just solving abstract equations. They are fighting a desperate battle for the very foundation of empirical science and our place in the cosmos, trying to prove to themselves and to us that the world we see and the lives we lead are more than just a beautiful, intricate, and ultimately meaningless dream. So where does this cosmic rabbit hole leave us? You and I. We have journeyed to the desolate end of time, we have wrestled with the maddening and paradoxical logic of infinity, and we have been forced to confront the chilling possibility that our very existence is nothing more than a statistical fluke, a phantom of the void. Are you a real person, experiencing these words in a real, shared world? Or are you a Boltzmann brain, a lonely, disembodied consciousness experiencing a pre-packaged phantom memory of a life just moments before dissolving back into an eternity of chaos? The paradox, in a purely scientific sense, remains unsolved. There is no definitive, universally accepted proof to rescue us from this profound, existential doubt. But perhaps the very existence of the paradox itself, the very fact that we are here discussing it, gives us a powerful clue. The fact that we can even conceive of this problem, that we can use the tools of logic, mathematics, and reason to question the nature of our own reality, is in itself a powerful piece of evidence in our favor. Think about it. A Boltzmann brain is a product of pure, unadulterated chaos. Its thoughts and memories are fundamentally random imprints. What are the odds that such a randomly generated brain would possess a perfectly coherent, logical, and internally consistent set of memories that lead it to deduce the very possibility of its own illusory nature? It seems far more likely that a random brain would have bizarre, nonsensical, and disjointed thoughts. Our ability to do science, to observe a universe that operates on consistent mathematical laws, to trace back a 13.8 billion year history that perfectly and logically explains our own existence, is a powerful argument against randomness. It is a powerful argument for order. The world we perceive is incredibly, breathtakingly structured. The laws of physics are so finely tuned that even a minuscule change would make life impossible. The history of the cosmos is a grand, sweeping narrative of cause and effect, of stellar evolution and galactic formation, of chemistry and biology. It feels coherent. It feels real. This is not the signature of a random fluctuation. It is the signature of a deep, underlying and consistent reality. Perhaps, then, the ultimate takeaway from the Boltzmann brain paradox is not that we should despair in a cloud of solipsistic doubt, but that we should be in awe. We should be in awe of the profound and beautiful fact that our universe appears to be a place that creates observers the old-fashioned way, through the glorious, slow, and methodical process of stars, planets, chemistry, and evolution. It is a far more difficult, more intricate, and ultimately more meaningful process than the sterile randomness of quantum chance. The paradox serves as a stark and humbling reminder of how strange, how vast, and how counterintuitive the universe can be at its deepest levels. It shows us that our common sense, evolved notions of reality can be completely upended by the logical implications of our own best scientific theories. It forces us to be humble in the face of the cosmos. In the end, without definitive proof, you must choose what you believe. You can accept the cold, bleak, statistical argument and live with the gnawing doubt that your life is a fleeting illusion. Or you can take the incredible coherence of your own mind, the unwavering consistency of the world around you, and the shared experience of billions of other human beings as powerful, empirical evidence that we are all part of something real, something shared, something meaningful. The evidence of your senses, the power of your logic, and the depth of your emotions are all you truly have, and all of them are screaming, in unison, that you are here, that you are real. Perhaps, in the face of ultimate cosmic uncertainty, that has to be enough. The Boltzmann brain is a terrifying idea, a ghost that haunts the hallowed halls of modern cosmology. But for now, it is just that, an idea, a profound and disturbing thought. And you are the one who is here to think it.